Presenter is San Vijay. So his project explores how AI-driven virtual assistants can help reduce analyst fatigue and improve efficiency within Security Operations Center. So please join me in welcoming San Vijay. San Vijay, the floor is yours now.
Hi, can everyone see my screen?
Yeah, I can see it.
Sorry,
Yeah.
and okay, sorry. All right, as mentioned, the bridging the gap, the AI-driven virtual systems for mitigating analyst fatigue and security operations. This is the agenda for my presentation. Introduction to the problem statement. Analysts, especially junior analysts, experience high workload, fatigue, and this might cause human errors during investigation during long hours. And sometimes they're struggling to interpret cyber incidents without senior guidance. The motivation for this project is to improve using AI to improve the manual investigation, to upskill the analysts with reasonable explanations. A background of this project is that analysts is using a static way of doing manual investigation, and I would like it to be more of retrieval augmentation generated using RAG to verify these contexts, these data from the alerts, cyber alerts. More related to the work, why I came up with this research, is that at my current job, I'm experiencing similar issues. So this research is factoring the human stressors, the interface evolution of natural language, the technical reliability of RAG and AI LLM, system context, can this be used effectively? And using standardization from MITRE attack and Sigma rule to provide a universal language pattern for interpreting the logs. One of the most important things that my approach for this project is to understand what are the problems? How can we mitigate this fatigue? How can we filter out these high volumes of SOC logs? And the recommendation is to use AI assistance. Upon testing, 30% reduction was reduced for manual investigation. And the upscale is to provide a reasonable explanation to help teach a junior analyst. And also provide security guardrails to protect the sensitive data information from the AI response. Give me 2 seconds. My team's, okay. The design pattern is a 3-tier system architecture. I actually designed this project using open source on my local Mac computer. And the priority was to have a 3-tier approach with monitoring using Wazuh stack, the manager, indexer, and dashboard. Number 2 is the intelligence, use end-to-end orchestration to help automate things. Tier 3 was the atomic red simulation. Use this to simulate cyber attacks so the AI can actually interpret the logs. On the right side is the host Mac OS, which is my Mac. It's a 2019. It doesn't have unified memory, but I was able to get it to work. On the Mac, I installed VMware. In VMware, I installed Ubuntu, Windows 11, Kali Linux. It turns out that Kali Linux was too much for my computer, so I disabled it. Inside Ubuntu, I installed Docker Container. In Docker Container, it has the daemon, which is Wazuh, and N8N, which is the AI workflow. Outside of the Docker container, in Ubuntu, I install Atomic Red to do simulation attack, and a Wazuh agent to monitor those attacks, since Wazuh cannot interpret the kernel level, I install atomic red so Wazuh can interpret those logs from the kernel level. Next is Windows 11. This was used as a client to have a use case, a sample size to say, hey, these attacks can actually happen in Windows. So Wazuh can actually interpret these attacks. So the agent is installed. And number 6 is a traditional Kali Linux attack machine. And the bottom, the LLM Ollama, this is a tool that I use to install LLM open source. And that's actually installed on my Mac machine. I just put it out of the scope of the architecture. Give me 2, so let me just move this. The implementation and technology use, I use Docker Composer on Ubuntu to run Ollama. And this is to use for my Mac because of issues with running LLM directly in Docker. So I installed the LLM actually on my Mac for hardware acceleration. And this helps to speed up the process for the alerts. And the domain is the actual semen detection, the orchestration, generative AI, atomic red for adversary emulation, infrastructure, and the framework. On the right side is the intelligent loop is the and would automatically fetch the Wazuh logs via API. And this actually helps detect the signal rule and the MITRE attack framework for atomic context. And below is the platform and components that I used to build this project. Now, the data collection, so basically I run atomic red to simulate the attack. So I have enough events so the AI can scan Wazuh and interpret the logs. So my purpose was to reduce 30% manual triage reduction and 90% experiment agreement rate. This is avoid the set in context guardrails so the AI could actually return without hallucinating with different response. So I want to make sure that there was 90% return rate. And then this process, I used 6 participants as a sample. As you can see on the right, there's a video that shows I used the full atomic red for this purpose as part of the data collection. And my goal is to have 10 minutes for each participant using the AI tool, and the low audit logs was 5 minutes. And for medium critical AI response. Upon investigation of the data analysts, the query, I actually use 5 interns in cybersecurity and 1 junior analyst for this project. And this is based on the actual trying to figure out these alerts. And they use the iPhone start-stop to manually investigate. And below the Q1 is for the critical is 5 minutes. And as you can see below, it's cascading. As you notice, there's a discrepancy between Q5 low and Q6. This is because the investigation with the AI was asked to run complex queries. The intern wanted to see how well it could search. And with the processor using my laptop, the result wasn't that great. As you can see, I rounded out the number, so it was like 14.9. I made it 15, and vice versa. So the achievement was 30% on average. Within the research findings, as you can see, I mentioned Q5 and Q6. With the medium response rate when it comes to time save, if you noticed in the lower level, there's batch. That means the intern was actually running different commands to test to see how well the AI responds. So the results was successful, but it was slower. That's because it's trying to search context, and the inquiry was delayed based on my processor and GPU speed. For a technical force multiplier is to achieve 30% reduction time in triage, and also 90% agreement rate. And And this is also important for the paradigm shift with the analyst's well-being to avoid burnouts. So Socratic interface actually is to mitigate alert fatigues and continue upskilling junior analysts by teaching the why behind the what. And the operation necessity is to use the information that's been interpreted by the AI to help and provide security guardrails to empower, to pivot, to reduce the alert, to be more proactive when investigations. So the AI is actually beneficial because it's scanning and compiling knowledge from the research and query and interpret that to provide output so the analysts can actually see that information instead of manually investigating those resources. Oh, sorry. For the future work, I thought about a whole bunch of things, the idea that I have. Where can I move from this project? Well, the prototype can be market ready. If I install this prototype, it could be on AWS, VPC, Google Cloud, Microsoft, Azure. But I recommend in order to protect these local open source, it's actually to install it on the premises. And this will be more effective to secure the environment. Part of it is also to make this project autonomous, to use this to continuous threat hunting. So this will actually help neutralize the attack using Wazuh, and it could be also involved with the AI can also integrate with other SEM like Splunk. So this project is based on Wazuh. Here's a quick demo of the project. So I use this project. I could actually use it for Windows, but in this case, since I was using the Ubuntu server, I actually run the Atomic Red attack to generate security logs on Ubuntu to simulate the attacks to generate cyber. As you can see here, it takes about 10 to 20 minutes to run a full Atomic Red simulation attack. As you can see, Wazuh generates some security logs. Oh, wait, sorry. My screen. It's not playing. Give me two. I'm not sure why it's not playing. Sorry. So that's, again, I said this takes like 10 to 20 minutes. And then this is to generate security attack logs, as you can see here. And this will be used in Wazuh for manual investigation. All right, so the second thing, I want to see if I could pause this for a second in this video. Part of my project is to understand how to integrate AI to an actual current production seaman or a vendor. Since I'm using Wazuh, I had to find out how to use API to see what's under the hood of Wazuh. So this API tool that I use is Postman. In Postman, I was able to see how Wazuh interpret the code to search queries and attacks. So I actually use this to have the AI query these codes so it could actually prevent it from hallucinating. And as you can see in this demo here. Now, in this portion is the actually orchestration. Sorry, give me 2 seconds. The Teams is blocking my. As you can see, this is the AI agent, the agentic agent that's built in N8N. And this agent can be integrated with anything. Indeed, you can integrate it with Splunk. It's pretty much like open to do for any integration for any platform. But in this case, it's a cybersecurity platform. As you can see, this is the agent. In the agent, I treat the agent as an employee. Just say an employee that's has a job, has a role. Then in this case, I just highlight something. You're a SOC analyst, a virtual SOC analyst, and your job is to find and summarize alert attacks from the HTTP. That's the indexer for Wazuh. And pretty much it tells you more detail. I could show you that after the demo, how more in detail. Next is the indexer. The code that I copy from the API, I use it and modify it. So this project can be extended. I could add more code to tell the AI to, check NST, check Reddit, check different things to find vulnerability. So this can be interpreted and give recommendation and solution for these new attacks. So in this case, because it's just a prototype, oh, shoot. In this case, it's just a prototype. Just go back, pardon me. So I left off at the indexer. So the AI has memory. You can use different memory. So the memory is for the context retrieval and storage. To say if you have I did as a query previously, it will store it in memory. And the memory is, in this case, you can use short-term memory for quick incident response storage, or you can use long-term memory like Redis, different type of vendors that you could add. And the Ollama is the chat module that I use for my project. As you can see here, I use Meta Llama 3.1. I was experimenting with Gemma, which is part of Google open source LLM, but it seems to me that Llama 3.1 works best for this particular project. And then and below, I will engage with the AI to ask a query. As you can see here, I'm asking the AI, hey, can you give me the last 10 security logs and summarize it? It typically take, as I mentioned in my presentation, it take because of my computer. It typically takes like 5 minutes, as you can see, as I mentioned. 5 minutes. It ran 5 minutes 22 seconds, and it gives the results on the left. It gives a security recommendation. It scanned Windows and Ubuntu and give a recommendation to what to look for. In the middle is the security logs. This is for the AI. It tells you the process, how it works for the agentic. It stores a memory after the chat, and it queries the alert, and then eventually it stores the query in memory and then return it back to the chat for output results. On the right is actually what it looks like for a typical cybersecurity incident response with the input, and that's what's typically look under the hood of an AI Siemens system. This is the key reference, and I'm open to questions. Sorry about my demo. My Mac is just like acting up.
No problem, San. Oh, thank you for your presentation. We'll now open the floor for the questions. Does anyone have any question?
This is the actual project, but it takes like 10 minutes to load. As you can see, the actual workflow. You could build different agents. Like I built one with Google. but they use tokens. As you can see, Google is different. This agent is built differently. And it could search anything. You could connect this to, let's say you want the AI agent, you could connect to Slack to actually have a conversation. You don't have to see the back end. This is the back end side of the system. You connect it to Microsoft Teams. So you can speak to the agent in Microsoft Teams, and this is part of what I find this project very interesting.
Yeah, this is a very cool project.
Yeah, sorry the demo. I wanted to demo the full project, but I realized that it'll be cool if I had more time to demo it like live. But it takes, because of my computer, the processor speed is not great. But if I have more GPU and going back to those things, I could integrate this with an AWS. And I was worried about API tokens, so I started building a project with Google and Claude, and I realized that it took all my tokens. So I ended up using the open source version, and it worked. I was like, I could query anything all day. How's your day? It'll respond to me. One thing I want to point out for this project, and from a security standpoint, the reason why I didn't want Google, because I spoke to different pen testers, and they said that when they do pen testing, the organizations do not allow AI to pen test because of security reasons. And so he said that you have to do the static way of the red team. But if companies are worried, they're more concerned about security, how are the data encrypted, and what vulnerabilities. So building this project in-house, where a controlled environment, your own hosted service, AWS, or vice versa, it could run seamlessly for the employees. And one thing I want to point out that for junior analysts, I think it's great. I think it's a good benefit. But if the cons of that is that if the manager see this, that AI can actually automate and do these things, then the job opportunity market might be less. I didn't put that in my report, but this is beyond the conversation.
Okay.
Vijay, you have a question for Morgan.
Yeah.
Well, number one, would you do this in Cybersecurity Club? That's number one. And number, well, we're reforming Cybersecurity Club that is open to alumni, because now you don't have classes. And could you do an analysis of your tasks? Because what it's designed to do is make you more efficient, not replace you.
Yes. That is a good point. I don't want to answer that, because my role is to let's see how we could be better use tools that we have. And in my current job, our employees are pushed back to I'm planning to roll out Copilot, but we have pushback. So I'm having like a kind of diplomatic challenges. I'm not sure if I'm using the right word, but yes, I could run this tool. I actually could connect it to Indeed and show how to modify your resumes and do things like that. Depends what you like me to do. If this is the project you like me to show, yeah, definitely.
Okay.
Good job, Vijay.
Yeah, thank you, San, for sharing your research. Now